Hi everyone, welcome to this video where we are going to discuss the solutions of JEE Advanced 2022 Paper 1 Physics. So as has been the feedback of many people who have taken this exam or have analyzed it after the exams, this turns out to be a moderate to lengthy type paper because it's not like questions are very difficult, you cannot even solve them. They are solvable, but definitely they are a little time taking. But of course, if you follow a little bit of strategies, little bit of tricks, you may be able to solve these questions in a little lesser time also. So we're going to see all of those things in this video. And let's start with it. Like over here, in the physics section, the first question actually that came up was from this topic of gravitation. Basically, here you're supposed to find the escape velocity in a certain case. So here it's given that there are two spherical stars, A and B, having the same radii. So like this is the star one. Let's draw it in pink color. This is like having some mass Ma, and similarly is another star of same radius but having different mass because it's given it is having a different density. MB, let us say, is the mass of this star. Radii of both of them are same. So let's call it R0 R0. R0 R0 is the density radius of both of radii of both of them. Now it's given mass of the first planet is half of the mass of the second planet. That is given over here. Mass of B is twice of mass of A. Okay, I have written it in lowercase. It's given in uppercase. Does not matter. In the end, we have to find the ratios. Now we can easily find out the escape velocity because we know that if there's a planet of radius r, mass is m, its escape velocity is basically root 2 gm by r. But there is a twist in this question. It's a JEE advanced question. There had to be something great. So here it says a part, as you can see, a part of the star A is lost and it gets deposited onto the second mass, on the second star. So it is given that it is halved in such a way that its radius becomes half. So that means it loses mass and becomes of R0 by 2 radius. So you guys can think, if R0 by 2 is the radius, we know if and it's given density remains constant. Yeah, it's given that density remains constant. So we know for this planet or for this star, mass should be proportional to volume, which is proportional to R cube. So if radius is becoming half, mass must have become 1/8. So the final mass is actually going to be Ma by 8. So where is that rest of the 7 Ma by 8 gone? All that mass got lost and got deposited onto this other star. It's given in the question that it is transferred in such a way that if this happens, the mass of this planet is given as Mb. Over that, this 7 m by 8 gets deposited. It gets deposited so that it, let us assume, forms a new radius, small r. So this is the question given. Like this deposited mass is 7 m by Ma by 8. Now we are supposed to find basically what is the new radius to be able to find the escape velocity. So for this, nothing, we are going to just say that this mass or this volume has created the increase in its volume. That is given. And it is also given that this new layer which has deposited is having the same density as this. So it's like mass is, if mass has increased by a certain value, volume has also increased by the same amount. So over here, guys, let's do it. We can say that the mass deposited in this case is going to be the, sorry, I should talk about the volume deposited. Yeah, I should say that the volume that got deposited on it must be the volume of the outermost part minus the volume of the inner part. Now it's given that the volume deposited is going to be density of this planet multiplied by its volume, which is, in my opinion, like you can think about it, should be volume is density, mass upon density. So mass is given as 7 Ma by 8. Density of this body originally, as you can see, was Ma divided by its volume, 4 by 3 pi r0 cube. This is equal to final volume of this outermost covering, which comes out to be 4 by 3 pi small r cube minus the volume of the inner layer of this covering, that is minus 4 by 3 pi small r0 cube. So guys, when you start solving it, you will get an answer in the end. Let's see what we will get. So in the end, when you calculate it, comes out that R0, sorry, we are calculating R. I should express that. In this, the value of R comes out to be R0 into 15 to the power 1 by 3 divided by 2. This we get as the value of the final radius of this covering. Now in the question, if we see, originally we are asked what is the ratio of their escape velocities, VB by VA. So we'll have to individually find out the escape velocity of each of them. So from the first case, we can say escape velocity is going to be, the formula is root 2 GM by R, root 2 G into mass of this, which is actually MA by 8, divided by its radius, which is R naught by 2. And when you're finding the escape velocity from the second one, VB, it's going to come out to be root 2G into mass of this, which is actually the combined mass of MB, which is given as twice of MA. We need to substitute that, plus 7 MA by 8, divided by its new radius, which is smaller, which we have found out this one. So when we go about finding out the ratios, VB divided by VA, guys, when you substitute the values, it will come out to be 2.3. That will be the answer. Like you can see over here what the question was. It says VB by VA is what? Root 10 by this. So when you calculate it, it will come out to be something like this. Let me show you. VB by VA, VB divided by VA comes out to be as expression something like this. Root 23 divided by 15 to the power 1 by 3. You can see 15 to the power 1 by 3 is coming from somewhere over here. Now, what was the question? That this thing is equal to root 10n by this. So it comes out 10n is 23. So from this, as I said, 10n is 23. So n comes out to be 2.3. Okay. So that is how we get this first question. Moving to the second question. Now, this is one question where like at different places when you try to find the solution to it, they have made small mistakes somewhere. I'll tell you the complete solution of it, how to actually like get it right. Considering a couple of factors which I will discuss. Here they are saying 16N7 plus 4 He2, basically alpha particle, this is what we call it. These two combine to give this. Now in the question it's given that we are supposed to find minimum kinetic energy of the alpha particle so that this reaction happens, and it is given also that this nitrogen atom or nucleus is at rest. Now, what is the condition for minimum energy? Now, many people have assumed that it is moving towards right with V1, this is moving towards left with V2. We have to ignore it. No, that cannot be ignored. If there is conservation of momentum, it cannot be ignored. The correct solution for it will be, guys, you will have to consider this nitrogen is at rest, which is given. Helium will come with some velocity, some initial energy it will have, which actually we are supposed to find. Let's call it U. So when it hits it, when they talk about minimum kinetic energy, guys, the condition for minimum is that after these two undergo this reaction, both of them move together. The hydrogen plus oxygen system, these move together with a combined speed, V. This is the condition of minimum kinetic energy. If we say that there is a possible more than this kinetic energy, possible value more than this, then it would mean helium will, hydrogen will move in a certain direction, oxygen will in some other direction in another speed. They are not moving as together as a single mass. But the minimum condition for minimum is that move together. Okay. So first of all, it is given the different energies, the masses are given. Initial mass of this is given, of this is given, if this is given, of this is given. So when it do the calculation, it turns out that the energy is basically, in this case, more for the products than for the reactants. So energy difference, if I talk about the energy difference, is the mass of the products minus the mass of the kind of reactants, the parent nuclei and all that stuff. Yeah. So that comes out to be the mass of this hydrogen plus this oxygen. That is 1.008 plus 19.003. Let me write it. 1.008 plus 19.003 minus the mass of reactant 16.006 plus 4.003. So this comes out to be approximately 0.002 atomic mass units. But in atomic mass units, you can convert it into energy, mega electron volts, by multiplying with 931. 930 in this case. So mega electron volt per unit joule. So it turns out this number comes out to be 1.86 mega electron volt. Now, guys, this is not the final answer. That is not the final answer. Basically, that is the extra energy reactants need to have coming when products got dissociated. But it does not mean that alpha particle needs to have this much energy only, because even when this alpha particle hits it, it does not just go into this increased mass. It is certain that it will have some momentum. So we are not going to say that this kind of thing happens, that same energy gets transferred to it. There has to be a momentum finally going in this combined system also. So the real way that you're going to actually do it with this, you will say that from conservation of energy, the kinetic energy of this helium, MHEUE square, that is going into two things. First of all, it is going into this increase in energy, plus it is also going into this final kinetic energy of the combined system, half into mass total finally into V square. But then we don't know the value of V, but we will get it from conservation of linear momentum. We would say mass total into V is equal to mass initial, which is of helium, into initial speed. So just substitute it. When you guys do the calculation, it will turn out that half mHEU square, which is the kinetic energy of this helium particle, alpha particle, which was actually asked in the question, that comes out to be the delta E multiplied by mass of the total system divided by mass of this oxygen. Sorry, not oxygen, nitrogen. So this will come out to be 1.86 multiplied by total mass, which comes out to be like 20.01 something. You can approximate it, because even in these kind of questions, we have to give up to 2 decimal places. A couple of decimal places are actually allowed. They are actually flexible for it. Divided by 16 point something, it will be. So this answer comes out to be 2.32 mega electron volt. This is actually the answer, not 1.86. Okay, so that is how you're going to do this question. Now let's move to the third question. According to me, this was the most easy question of JEE Advanced Paper 1 Physics. Here we are supposed to find the charge stored on this third capacitor C3. Just imagine, across its two ends, it's directly given what the value of the potential difference is. One terminal directly connected to this, another terminal directly connected to this. So for this capacitor, we know that potential difference is 2 volt and capacitance of it is 2, or what was it given the value of C3? 4 microfarad. So it's done. The charge is C3 into V. That is 8 microcoulomb. That's it. The most easy question according to me. This is an interesting question. Here they have asked what's the value alpha, angle alpha that will be formed of the image if the object is present at an angle. Mostly a geometry question. Here you have to use the fact that image of an object is formed point by point. So if the object is this, the bottommost point on the principal axis of this object, its image is present over here on the principal axis only. And of course, the point which is at some height, its image is also at some height. So a little bit of geometry we will use, we will get the answer. Most of the things are given in this. Focal length is given as 10 centimeter. This distance is given as 40 by 3. This angle is given. It's 2 pi by 3 given. I am more comfortable with degrees. I'll write it as 60 degrees so that I can use trigonometry. It's given that this length is 2 centimeter over here. Let's draw that also over here. This length is 2 centimeter. And what else is given? Height of the image. This height is given, already drawn in the figure itself. Alpha we are supposed to find. So all that we have to do is take these 2 points. Let me call this point as A, the green point is A, and this pink point as B. So first I'll write the equation for point A. For point A, if I use the length equation, I'll get 1 upon VA minus 1 upon object distance for A, which is minus 40 by 3. So minus 40 by 3 over here is equal to 1 upon focal length, which is 10, because the convex lens focuses on the right hand side, so it comes out to be this. So when you will calculate it, VA in this case comes out to be, it's calculated, 1 upon VA is 1 upon 10 minus 3 upon 40. So that comes out to be minus 1 upon 40. So yeah, VA comes out to be 40 centimeter. I'm so sorry, yeah, it's a positive value, yeah, positive 40 centimeter. So this comes out with the value of VA. So basically we have got that this length is 40 centimeters. Now similarly for point B also present over here, we will write the equation. For B we will say object distance. See again VB minus 1 upon object distance. Now what is the object distance? What is this distance in total? Up to this it is 40 by 3. And here it is 2 cos 60 degree, which is 1. So this comes out to be 43 by 3 in total. This total distance is 43 by 3 centimeter. So according to this, it will be minus 43 by 3 is equal to again 1 upon 10. So it turns out that VB is equal to, again I'll have to calculate it, the boring stuff. And we have to be very, very quick at these calculations if we want to solve questions in JEE Advanced. Like these kind of calculations should not take a lot of time. 3 by 43. Do the calculation. We'll take the LCM for 3. That's 43 minus 30. That's 13 by 430. So it turns out that VB is 430 by 13 centimeters. Such an ugly number. 430 by 13. So anyways, this comes out to be 430 by 13 centimeter. Now all that is left is using trigonometry. It's given that the value of alpha is pi by n. So we grade 11, 12th people know that it is like know the values of only pi by 2, pi by 6, pi by 3, pi by 4. So only these possible values must be there. So but anyways, let's calculate it. Tan alpha is equal to the height, which is 30 root 3 by 13. Now we know where this 13 is coming from. Divided by this width. Now we know. This we have found. This was already given. So it's going to be 40 minus this length found out 430 by 13. So when you calculate it, it turns out to be 1 by root 3. That means theta is for alpha is equal to pi by 6. So the answer is 6. That value of n is actually 6. And now moving to the next question. Here in this 5th question on the paper, it's given, it's interesting. Like I love these kind of questions where like they mix up a couple of concepts. One concept over here is from kinematics of rotation, other is from projectile motion. So here they're saying, and rotation of course is also there, pure rolling motion. So it's saying that it's a sphere of radius, it's a disc of radius 1 meter. Let's take R to be 1 meter, and it is at rest because it starts to roll. And alpha is given. It's given that its angular acceleration is 2 by 3 radians per second square. So you can imagine it's going to speed up with time and all. Now it is given that after a certain time t, a stone detaches itself, which was stuck at the bottommost point in the beginning. Like this stone at t equal to 0 was present over here. But after a while, after how much time? Root pi seconds, it detaches and starts moving. So first we need to find out how much has the stone moved? Where is the stone? With what speed is the stone moving at the time it detaches? So fine, not a big issue. We can do that. It's like solving 3 small questions in the same question. We can easily do that. We will say, first of all, from angular motion, theta is equal to half alpha t square. Using second equation of motion for rotation, it's going to be half into 2 by 3 into time square. Time is root pi. So root pi square. So this guys comes out to be pi by 3 radians. Oh, pi by 3 is like 60 degree. Great. So particle is present at 60 degree angle with the original position when it is attached. Okay, this we have found out the stone is over here. Now the next question is, what is the speed with which it is thrown? So for finding out the speed, we are going to use the first equation of motion, v equals to alpha t, because initial velocity was 0. Oh, I should not call it v, I should call it final angular velocity. So this comes out to be 2 by 3 was the value, yeah, into time, which was given as root pi. Great. So that's 2 root pi by 3 radians per second. But we are supposed to solve it for projectile motion, so we need to take its linear velocity. So we can say linear velocity is r into omega final. Now what's the value of radius? 1. So it just multiplied with 1, we get 2 root pi by 3 meters per second. So this particle is going like this with speed 2 root pi by 3 meters per second. Now we know if these two lines form angle theta, their perpendiculars also will form angle theta. So it goes at an angle of 60 degrees with the horizontal like this. What are we supposed to find? In the question, we're supposed to find what is the maximum height up to which it reaches from the ground. Like this, what this maximum height is, we are supposed to find. But for that, first thing that we should know is what is the value of this height, right? How much it has moved because of rotation. This value we need to find first. So that is also not difficult. We can use a little bit of geometry. We know that this radius is r, this radius also was r. So can we say that the small height h is basically r into, like, r is the total height minus r into cos theta, the projection of it on the vertical side. So that's r into 1 minus cos theta, cos 60. Cos 60 degrees half, so it comes out to be r by 2, which is half meter. Okay, and that is why if you notice, this maximum height formula, which is given in the question, h max is equal to half plus x by 10. So this half is coming from here, that this half is already known. We just need to find the rest of the height. Like from here onwards, what is this height? So it's basically a question of normal projectile. It's given that initial speed with which object is thrown is 2 root pi by 3 meters per second. It is thrown at an angle of 60 degree. We are supposed to find maximum height. So that h max, maximum height up to which it reaches, which is x by 10 in our case, is going to be, we'll use that formula, v square sine square 60 degree divided by 2 into g. I'll assume it to be 10, which we generally do. So guys, when you will calculate it, it will turn out to be 0.52. You will get that the value is 0.52 as x. So now after that, moving to the sixth question of this paper, a solid sphere of this mass and this radius basically is rolling on this without slipping. So we are supposed to find, let me tell you in short, we are being asked what is the angle of, the acceleration of center of mass of this sphere. Now, of course, if it is purely rolling, it is going to rotate with some alpha also. So whenever something is purely rolling, we know that this point at which it touches the ground most probably should be the point of rest, because like only in the cases when the surface is not moving in itself. So surface is not moving. So we can say that this point stays in contact. It is going to be the instantaneous axis of rotation. And we can use that concept. You can do it from ground frame also, like using the center of mass also you can do. I should not say ground frame, using the center of mass concept also you can do. But you can do it for instantaneous axis of rotation also. We will draw the free body diagram for it. So we can say that in this case, one force is mg sine theta at what's the radius? Okay, I'll represent it as capital R. Capital R is the radius. Then there is a couple acting, a force equal and opposite acting at some distance. The point of application is not same. One F is in this direction at a distance smaller from this. Another F is in this direction, again at a distance smaller from this. So when you write the equation for instantaneous axis of rotation, when it is rotating about it, you will say torque about instantaneous axis of rotation is moment of inertia about instantaneous axis of rotation into alpha. So what's the value of torque? You can see that easily. One torque is going to be because of the weight, mg sine theta into distance r, because that is the radius of it. Plus, because of this yellow force also, there will be a clockwise torque. So we're going to say F multiplied by R minus small r. But because of this other force F, there's an anti-clockwise torque. So we'll have to subtract it, considering clockwise to be positive. So it's going to be F into R plus R. This is going to be equal to the moment of inertia about the instantaneous axis of rotation, which you can use parallel axis theorem also to find. So we can say moment of inertia about instantaneous axis of rotation will be the moment of inertia about center of mass plus m into r square. Since it's given to the solid sphere is going to have 2 by 5. So 2 by 5 mr square plus mr square. So we get that this is equal to 7 by 5 mr square alpha. That's it. Most of the question is done now. From this, you're going to find the value of alpha. Whatever answer you get, you can see like capital R will get cancelled out over here. You can see that easily. Some calculations will be done. Alpha you will find. And whatever alpha you find, since it is purely rolling, not slipping over it, you will say acceleration of center of mass is equal to Rm. And when you substitute the values in this case, it will turn out that it is equal to 2.85 meters per second square. Okay, and then you get the answer. So with this, we will move to the next question now. Yeah, so now this is one question where like solution is given present incorrectly at many of the platforms where you tend to find the solutions. See, in this case, they are saying there is an inductor and a capacitor placed like this. There is a circuit like inductor capacitor, and in this entire plane, there is an into the plane magnetic field present like this. And this B is B naught plus beta into T. So as soon as we see magnetic field is changing with time, we know there must be some electromagnetic induction taking place. So area is given, magnetic field is given. So we can find out the induced EMF using Faraday's law. Induced EMF is going to be rate of change of flux. What's the value of flux? Flux is B into A. When you differentiate it, constants will go away. Only that term with T in coefficient will be actually left. So this will guys come out to be beta into A. Beta into A comes out to be the induced EMF. Now we know that induced EMF, if there's this induced EMF, just a second, we can like place it in the circuit equivalently by a battery of induced EMF. Inductance in L, induced EMF, let's call it small e. Okay, I'll in short call it small e, right to write EMF every time. I'll just call it small e. So now over here, if current is flowing, what are we supposed to find? Let's read the question once. In the question, we're supposed to find the maximum magnitude of current. Like what is the maximum magnitude of it? We are going to use KVL because in such questions, we always use Kirchhoff's voltage law. So let us say some charge has been stored plus Q on this minus Q on this, and some current is flowing right now. Let's say I. So according to Kirchhoff's law, it will be E minus Q by C minus L di by dt is equal to 0. That is Kirchhoff's voltage. But if they're asking, like this is true in general, this equation is true in general. But when they're asking, there is maximum current. So maximum current means if there is maxima of current with respect to time, can we say di by dt is equal to 0? That would make this term equal to 0, the third term of this equation. So what it means is when the current is maximum, at that time charge stored in the capacitor is C into V. At that time charge stored is C into V. C into, from this equation we can substitute beta. So what we have found out is the maximum, like not the maximum charge, the charge stored when current is maximum. We are still supposed to find the value of current. Now how would we get the value of current? So let me mark it as one equation. Now what most of the people have done is, and which we should do, is conservation of energy. Let's do it over here. Conservation of energy. And surprisingly, we get the same answer if we do the wrong thing also. Like what we tend to do is we forget that there's an EMF battery of some EMF. We tend to say Q square by 2C is equal to half Li square. That is completely wrong. There is a battery supplying energy over time. So how can we say over L and C system, energies will be same when current is maximum? That's completely wrong. You can never have that. Like you can never claim that. You will have that, but that is not the reason behind it. You will have to use the conservation of energy very, very properly. You will have to say that there is work done in the battery. Work done by the battery. Battery is doing some work. And that work is actually getting stored in the capacitor and inductor system. Energy is getting stored in it. They're not exchanging energies. So work done by battery is energy stored in capacitor, potential energy of capacitor, plus the potential energy of inductor. Now, what is the value of work done by the battery? That is going to be charge supplied by the battery till now, which is CE, which we have found out over here, multiplied by the potential difference, which was constant, E again. Energy stored over capacitor is what? C into E, potential is E over here. So we can say it's going to be C square E square divided by 2. Sorry, C E square divided by 2. Like I am using the formula Q square by 2C. Let me do it over here. Just a second. I'm using Q square by 2C, which I'll show you. Q square by 2C. plus potential energy stored in reactor half Li square. Now this equation also gets reduced to this. Half Ce square is equal to half Li. Charge stored in capacitor is equal to charge stored in inductor. And finally, we get the answer that the current stored, like the current that it flows is 4 milliampere. So the answer was an integer answer for this question, 4.00. So I hope that is clear to you. And now let's move to the 8th question given in this paper. Now this also is one of easy questions in this paper. Let's see what this question says. There is this ground and a projectile is thrown with some speed v at an angle theta like this. Like the speed is over here is v, angle is theta. And it says that it goes up. And when it was midway, in fact, when it was at the topmost point of it, then at that time, it enters from gravity into some other region which has a little different gravity acceleration due to gravity, where effective acceleration due to gravity is a little more than g. Point like g divided by 0.8, one little more than g. So first, and we are supposed to find the total range of this motion. Now, original range is given as d. Original range is d. So we can say d by 2 has already taken place, like d by 2 has already moved horizontally. Now, only thing that we are supposed to find is for this new motion, when it is at the topmost point, when it is already moving with v cos theta speed, if the gravity becomes g dash, then what is going to be the new distance traveled by it before it falls? So we need to solve the question only for this part. We would first of all find the time in which it falls on the ground. For that, we would say time of falling is root 2h by g. But then the question is, what is the value of the height h up to which it has reached? For that h, we will have to solve it for the left half motion first. So we would say from the left half motion, what's the maximum height? The maximum height for this is going to be v square sine square theta divided by 2g. We know that if it is thrown with speed v at an angle theta, this comes out to be the height. This we will substitute, but I'm so sorry. We will use the formula 2h by g, but g will be g dash in this case. So this comes out to be 2 into h, which is v square sine square theta divided by 2g divided by g dash, which is g divided by 0.81. So g cancels g, 2 cancels 2, and it comes out to be 0.9. Yeah, because 0.9 square is 0.81. 0.9 v sine theta divided by, sorry, g doesn't cancel. It's going to be square of g. So root of g square, that comes out to be g. So this is going to be the time in which it falls from this point to this point. But we have to find the horizontal displacement in the time that this has happened. So we can say that this new part, what should I call it? Let's call it d double dash. So this d double dash comes out to be the horizontal velocity v cos theta and the time for which it has moved to the right, 0.9 v sine theta by g. So you can notice it comes out to be 0.9 v square sine theta cos theta divided by g. So we can actually call it 0.9 by 2 times the original range d. This comes out to be the case. So that means our new range, the sum of them is going to be d by 2 plus d double dash. That is d by 2 plus 0.9 d by 2. So this comes out to be 1.9 by 2d, which is 0.95d. So this thing I think was given as n. So yeah, n comes out to be 0.95. So now let's move to the next question, which is basically about a capacitor in which there's a dielectric between the plates of two capacitors and the plates have been pulled apart. So 4 things have been asked, multiple correct type questions. So let's see what are the things. So first part that should be solved, that we should solve out of the 4 is the third part, where it says earlier there was a potential difference of V between the plates, between the two capacitor plates. What is the final potential between the new set of plates? So now see, even if the plates have been separated by like twice the distance between them earlier, the potential difference between the two plates is still going to be V only, which is applied on the plates. Like over here also potential difference is V, and over here also, because it is connected to the same battery for voltage V, potential difference still remains V. So potential does not change. So that means the C part definitely is wrong. Then the next part that we should try to solve is the second part, the first part actually. Now, at many places, the answer for A part is actually wrong, given wrong. So there's been a lot of confusion about it. Many people have asked me also what would be the correct answer for it. So let's see the first part. Basically, they're asking what is the difference, like what is the change in the electric field inside the dielectric. So first of all, they're asking us to compare the electric field between the dielectric earlier, before the separation of plates, and then after the separation of the plates. So between these two states, you have to find the electric fields like relation. Is it reduced by half or doubled, or exactly what exactly it is that has been asked. So see over here, earlier it was given the distance between the plates was d. So first you should visualize if the charge, so if the potential difference is v over these plates and the distance is d. So the electric field which is created externally in this vacuum, that was actually v by d, because potential difference divided by distance must be the electric field. Now because this electric field is present inside dielectric material, so inside the dielectric, it is going to reduce by a factor of k. That is like the general formula that we know, external electric field divided by k. So earlier it was V by kd, V naught by kd, V by kd, the potential difference by this. But now they're asking if the separation between the plates is double. Just imagine now the separation is 2d instead of just d. So what will be the electric field created in vacuum this time? Electric field created externally in this medium, that is going to be V naught divided by 2d. Because the separation is doubled, the electric field is halved. And that halved electric field, out of that also, the part of it which exists in the dielectric, that is again going to be the electric field, external electric field in this case divided by k, which is going to be V naught by 2kd. So we can see it actually has been halved. So A part is actually correct for this. Then moving to the second part, which is capacitance relation. Has capacitance increased, decreased, or what exactly has happened? So this is quite simple, general kind of question that they ask in JEE Main also, JEE Advanced also. What is going to be the capacitance earlier? Like C1, if I call it, that C1 earlier capacitance, or let's write it Ci, initial capacitance. So initial capacitance is the general formula Ka epsilon naught divided by T. But if we talk about the final capacitance, C2, so you can imagine we can relate, we can compare it with a system of two capacitors connected in series. So this capacitor has width d, and this one has d by 2, d by 2. So you can add it up to make it a single capacitor of width d with a vacuum inside. So here, since it's 2 in series, we're going to use this formula C1 plus C2. So it is going to be Ka epsilon naught divided by d multiplied by A epsilon naught divided by d divided by sum of them, K plus 1 A epsilon naught by d. So you know that this final capacitance comes out to be K upon K plus 1. Sorry, this is 1 upon, sorry, that's right. This into A epsilon naught by d. So this comes out to be the formula for capacitance finally. So let's see what the question was. Initial we have, final we have. They're asking, is the capacitance decreased by a factor of K plus 1? So see, earlier it was K A epsilon naught by d. Now it is K upon K plus 1 epsilon by d. So that means it actually is correct. The second part is right. It has decreased by a factor of 1 by K. There can be a little confusion about it. Some people might say it has decreased by a factor of 1 upon K or increased by a factor of 1 upon K, like decreased by a factor of K plus 1 or decreased by a factor of 1 upon K plus 1. So that can be a point of confusion. But according to what this question is trying to frame, in my opinion, it must be the correct answer, B. And then moving to the fourth part, the work done in the process depends or does not depend on the dielectric. So first of all, which work done are they asking? They're asking the work done by the external force, which is actually pulling this plate apart. So for that, we need to know the initial energies, final energies, and then comment upon it. So see, earlier there was a capacitance, some initial capacitance was there, which we have already found out, K epsilon naught by d. So what is going to be the initial potential energy stored? So potential difference is V. So we're going to use half Ci V1 square is the initial potential energy stored. And what is going to be the initial charge stored on this plate? So we can, for that we can say initial capacitance into V. Finally, this capacitance has decreased. You can see it is 1 upon K plus 1 of the previous value. So final capacitance we know it is going to be, the final potential energy will be half Cf V square. Potential capacitance has decreased. That means potential energy stored also has decreased. There is lesser potential energy stored now. And the charge also has decreased. Cf into V. This also has decreased. So how would we use the conservation of energy over here? Which energy is being lost, which energy is being gained? If you think upon it, you need to separate two plates with equal and opposite charges, plus Q, minus Q, capacitors, plates are separating. So you are doing work externally. But added to that is the decrease in potential energy, the loss in electrostatic potential energy stored. And all that, where is it going? It is actually going in the charging of the battery, in the work done on the battery. Why? Because earlier the charge on capacitor was more. Now the charge is less. That means charge is going into battery. You are charging the battery. So from this, you can say the work done by external force plus the loss in electrostatic potential energy, which is going to be initial half C1 V square minus final half CF V square. This is equal to the work done on the battery. What is the work done on the battery? The total charge that has been lost, that is Qi minus Qf into V. So if we substitute the values here, you will get Ci minus Cf into V square. So we find out that the work done by the external force, bringing this half Ci1 square Cf V square on the right hand side, you will get half Ci minus Cf V square. When you substitute the values of Ci and Cf, you will find out it actually depends on fold the entire circuit. The lower half we can fold onto the upper half. So this circuit becomes something like this. Like you can make this out of it. When the lower half is folded onto the upper half, you can imagine in this question it is given all resistances are 1 ohm each. So this also is 1, this also is 1. So you can imagine this when folded onto it will become 0.5. This also will become 0.5. This also will become 0.5. But these resistors which were there in this horizontal branch, they are not folded onto anything. So they are going to still possess the older value 1 ohm, 1 ohm. And the potential difference is E1 is given as 12 volt. So this becomes 12 volt and this becomes 6 volt. We are supposed to find current in a few branches. Now see, to make the question a little faster, solving it a bit faster, I am going to take 1.5 and 1 ohm in series. Like effectively I can make it. It's not going to save a lot of time, but yeah, certainly it will help us a little bit more to make the calculation a little simpler. We can do that. No harm in doing it, but we have to be a little careful by the end. So we will see what actually I mean by that. We are going to write the battery's potentials, 12 volt over here, 6 volt over here. And the resistances we know, it's going to be 1.5 ohms, 1.5 ohms. And this is 0.5, stays as it is. Now, since we're using nodal analysis, first of all, we'll choose a point of 0 volt. Let me take this as the point of 0 volt potential. This point I'll take as X. Reason I've taken it as X potential is because I know there's a battery of 12 volt. So potential on this point is going to be X plus 12, 12 volts more. And then again, there's a 6 volt battery. Potential here is going to be 6 volts even more. So X plus 80. Then we are going to use KVL, Kirchhoff's current law, KCL, Kirchhoff's current law, and say that current coming from this branch and this branch and this branch should sum up to become 0. So that means X plus 18 by 1.5, which is the current in this branch, plus X plus 12 divided by 0.5, which is the current in central one, plus X divided by 1.5 is going to become 0. When you solve this, guys, you'll get X is equal to minus 10.8 volts. On solving it, we get this. So we have found out the potential of this one. Now what are we supposed to find? The current. So for finding the current, you will state, because we know potential here is negative, so current must be flowing from higher potential to lower potential. So in this branch, the current is going to be 10.8 divided by 1.5. 10.8 divided by 1.5, which will come out to be, let's see, 3.6, 7.2 ampere. So current in this branch is 7.2 ampere. Now what exactly it means, we are going to see that in a while. Then after that, the current in the central branch you have to find in this branch. So in the branch in the middle of it, it's going to be X plus 12 divided by 0.5. X plus 12 divided by 0.5, 0.5. So that is going to be 1.2's double, that is 2.4. So 2.4 ampere will flow in the which direction? Upwards direction in this case. No, downward direction. Yeah, again it is. Just a second, let me think. Yeah, X is minus infinity. Yeah, it comes out to be positive. Basically, this point has positive potential. Current will be upwards, 2.4 ampere in this case. And similarly, we are supposed to find the potential in this branch. This point has x plus 18. X plus 18, if you calculate, will come out to be 6.2. 6.2? No, 7.2. 7.2 will come out to be. So current in this branch in the upward direction will be minus 10.8 plus 18 divided by 1.5. That is 7.2 divided by 3 by 2. Which will come out to be 2.4 into 2, which is 4.8. So 4.8 ampere flows in this. Does it make sense? 7.2, 2. KCL should be satisfied. That should be the condition. Let's check that very quickly. It comes out to be correct. Yeah, the three currents we have found. But you cannot directly use it because we have combined some of the resistances here. So if 4.8 ampere is in this branch, what we should say is 4.8 went over here and then it went over here. Similarly, this 7.2 was flowing in this branch and then was going in this branch. And this 2.4 was there in this branch. Now, again, where did we get this circuit from? From this, we folded. So just imagine, if I am saying in this circuit, there was this R3 resistor not folded over anything. So current through this should be 4.8. But this current, when we say goes into this branch of 0.5, which is like folded over of R5 and R6, and it's 4.8, then actually 2.4, half goes over this and half goes over this. Similarly, if we are saying 2.4 amperes flows in this branch upwards, then half of it flows in this 1.2 and half of it flows in this 1.2. Similarly, if we say 7.2 is flowing like this in R1, it will be 7.2 all of it. But it must be combining half from two sides, 3.6, 3.6 to become this. So let us check what is the final correct answer. R1, the current through R1 comes out to be 7.2. That's correct. Through R2, current is 1.2. This also is correct. The magnitude current through R3 is 4.8. That also is right. The magnitude current in R5, 2.4. Yes, all four of them are correct. And that is the correct answer. So this is how we have to be careful. We may have different methods of solving it, like our own calculations, our own steps, our own assumptions, but everything in the end will give the right answer. Now, this was the next question, like one of the most difficult questions I think there was in the paper. So let us see how we are going to do this question. So starting with this, here it is given, guys, that there is this chimney. Like it's a mixed question of thermodynamics and fluids. So this is what makes this a little difficult and interesting. Here it's given that the upper surfaces area is 0.4 meter square. This is the larger one, and the lower one is 0.1 meter square. These are the areas given. They call this one as A1 and this one is A2. A1, A2. Other than the area, they have given temperature also. They have given that the temperature of the lower one. Yeah. Here, let's call it T1. The temperature is 300 Kelvin. Okay. Area is given. Temperature is given. Let's see. Pressure also is given. Yes. They have given, the temperature of upper end is also given 150 Kelvin. Temperature of upper end is 150 Kelvin. They have talked about the pressure also, which is writing everything which is given. At the lower end, it is 600 pascals. P1 is 600 pascals. And at the top, it's not given. In fact, it is being asked, what is the pressure at the topmost point? Fine, we will use that in a while. Other than that, what is given? Here it's given the density of the gas. The density of the gas might be helpful somewhere in any of these parts. 0.2 kg per meter cube. Okay, very, very light gas, 0.2 kg per meter cube. And what else is given? Alpha. What is alpha? The rate of mass entering. See, from the units we can think kg per second. It is the amount of mass entering, mass flowing per unit time. It's the mass flowing per unit time. From the units, I'm going to guess that per unit time. That, guys, is given as 0.8 kgs per second. Okay. What are we supposed to find? Let's make a quick note of that. The pressure at topmost point. Here we have to find pressure. Velocity at the upper end and lower end. Okay. Speed of the gas, the velocity. With what speed they are flowing. We will see that. Height of the chimney. Okay, this height we are supposed to find. Probably Bernoulli is to be used. Bernoulli's equation is used whenever we have to find height difference from gravitational potential energy. And density is being asked. So let's start with it. Starting with the first part. Finding the pressure. In the question it's given, if you have seen, It's an adiabatic. Somewhere over here it was given, it's adiabatic expansion. It's adiabatic. And what else? Gamma is given. Gamma is given as 2. So pressure is given, temperature is given. Temperature is given at top, pressure is being asked. So we are going to use the adiabatic equations relation. P v to the power gamma is constant is the equation, but we want relation in pressure and temperature. So we can replace volume by some temperature by pressure term, and we can say this is constant. Basically, T into T by P square is constant. So from this we can say that pressure is proportional to temperature square, or we can say, that's what we can claim. So see over here, if they are saying temperature has become half while moving up, then just imagine pressure should vary by square of it. Square pressure should become 1/4. What's the pressure at the bottommost point? 600. That means, guys, pressure at the topmost point P2 should be 600 pascals by 4, which is 150 pascals. Is this given in the option A? No, it is actually not given. It's given 300. So that means first part is actually wrong. Just imagine, so much calculation. It turns out that it is wrong. That is what like JEE Advanced catches us with. Then moving to the next part, they're asking the velocity of the gas at these 2 points, topmost point and bottommost point. Now, how would we find velocity? Anything given related to how fast it is moving? Yes, mass per unit time is given. It is given that the mass flowing per unit time is this. But we have a formula. We learned the formula that volume flowing per unit time is area into velocity. But mass flowing per unit time is given. Can we find out volume flowing per unit time? Yes, we can find volume per unit time because we know volume is mass upon density. We can say it's mass per unit time divided by density. So volume per unit time we know is area into velocity at the bottommost point. We know area, velocity we can find. Mass flowing per unit time is given as 0.8 kg per second divided by density, which was given in 0.2 kg per meter cube. So see, it turns out to be 4 meter cube per second. The rate of flow of volume. 4 meter cube is flowing every second. Area was already given. So we can say 4 divided by A1. Area was given as 0.1. So it's 4 divided by 0.1, which is 40 meters per second. Was this given in the option? Yeah. Velocity of the gas at lower end is 40 meters per second. But we still need to check if at the upper end it is still true. If at the upper end speed is 20 meters per second. Now, how are we going to find that? Can we use continuity equation over here? A1 V1 equal to A2 V2. Now we cannot do that because it's an adiabatic expansion. It's not an incompressible liquid. Continuity equation is true only for incompressible liquids. So we cannot use A1 V1 equal to A2 V2. But what instead we will use is what is the process that drives this motion? Adiabatic expansion. So we cannot use this, but we can certainly use this relation. PV to the power gamma is constant per unit time. So we can say pressure into volume, like P1 into V1 square, because gamma is 2, equals to P2 into V2 square. But we are going to use it in some time dt. In time dt. Why? Because volume is continuously flowing. We will have to find how much volume has flown V1 in time dt. So we can say pressure into volume flowing per unit time. Can we say it's going to be A1 V1 is per unit time into dt. This square is equal to P2 into A2 V2 into d2 square. This relation we are going to use. We will get that speed with which the liquid is flowing at the topmost point is P1 A1 square V1 square by P2 A2 square. Now, when you do the calculation for it, speed will come out to be 20 meters per second. Was this given in the option? In the option, it was given 20 meters per second. Yeah, so this comes out to be correct. So this B part is actually correct. Now, since we are already solving it, we have the logic. We will directly go for the D part first of all. Because density is being asked. We already know a relation between density and all this stuff. We will go to the D part directly. We know that from the topmost point, let me draw it again. We are saying from the topmost point, it is flowing with some speed v2, which we have found out 20 meters per second. And what else was given in the question? It was given that the mass flowing per unit time is 0.8 meters per second. Mass flowing per unit time we know. Do we now know the volume flowing per unit time? Volume per unit time. Yes. A2V2. A2V2 is the volume per unit time. So can we say that a density, like the kind of logic we used over here, density at the topmost point should be the mass flowing per unit time, which is same throughout, mass is conserved, divided by volume per unit time. So this comes out to be 0.8 divided by A2V2. A2 is, I think, 0.4, and to V2 we have found out is 20. 20. So this comes out to be 0.1 kg per meter cube. Was this given in the question? 0.1 the sort? No, it's not given. So D also is wrong. It was given 0.05. It should be 0.1. So D part also. So that's how we get it. And now moving to the last part, C part, which is finding the height of the chimney. So as we discussed in the beginning itself, we are going to certainly use Bernoulli's equation for it. So from Bernoulli's equation, this is 0.1, this is 0.2. We can say, now the densities are different. We have to take care of that. Here density is ρ1, here density is ρ2, different density. So we will say using Bernoulli, pressure at 0.1, which is given as 600, plus density of this into G into its height, taking this as reference, 0, plus half ρ1 V1 square, all these things we know. P2 plus ρ2 G H, which we are supposed to find, plus half ρ2 V2 square. So just substitute the values. Everything we have found out. P1 we know is 600. P2 we have found out is 150 pascals. The original density also we know. Final density also we know. Everything you will solve and you will get H is equal to 590. So that actually is correct. So C part also is right. The answer for this is B and C. That's how we do it. So with this, now we can move to the next question, which is question number 12. And this is finally from optics, a question from optics, very much awaited. And if you see, it's mostly from geometry. It's not even a question of optics. We can probably do this question from grade 10th knowledge also. So let's see what actually this question says. It says there's an equilateral triangle. Let's see. This is the equilateral triangle. All three sides are mirrors. So each of this mirror is going to be at 60-degree angle and all. Now they are saying in the A part, they say light enters a ray of, okay, they are saying there's a hole over here. They have mentioned that at a distance small l, there is a hole when each side of the triangle is of length capital L. Light can enter from this hole only and exit from the hole only. So they are saying if light enters at an angle of 30 degree, the ray of light will come out. Okay, ray of light can come out if it is entering at an angle of 30 degree. Now, how would we solve this question? Let's see. Just use a little bit of geometry. If light enters at 30-degree angle, it looks like this. So just imagine it's entering at 30 degree. It's an equilateral triangle. So this angle certainly is 60 degree. So can you imagine from angle sum property, this angle is 90 degree. That means it's the case of normal incidence. Light will hit it, bounce back and come out of this hole. So ray of light will come out for this. The answer is yes. So A part is correct. That's simple. Never get scared by just looking at the image. Many people got scared by looking at this image, did not even try this question. This should never be the case. Read the question, try to understand it. If you have spent 1 minute on thinking on the question, then probably you can proceed further. But just by looking at it, you should not do that. Imagine this question just looked scary and you did not attempt it. You did not even care to spend 1 minute. But at the same time, you spent 10 minutes on some other question which you thought was solvable, but was not. So you should always look at all questions, understand what they're asking, and then decide if you want to skip it or not. They are saying there is an angle for L equals to L by 2. Basically, they are saying at L equal to L by 2, the midpoint of it, there is an angle for which ray of light comes out after 2 reflections. Is that possible? Just imagine. From symmetry, I go by symmetry. I try to imagine, is there any particular case with some symmetries? My favorite symmetry over here will be when light goes like this. Just imagine when it goes at 60-degree angle. How would it get reflected? Just imagine 60, 60. This angle will be 60, this will be 90. So this will be 30. And if it goes at 30, it will go out also at 30 like this, reflect at 30 degree. Can we imagine it become horizontal? Just think about it. These are like corresponding angles. This is 60, this is 120. Some of them is 180. That means these two lines are parallel, this and this. So again, symmetrically, it's going to hit over here and will reflect to pass through this again. So the question is, there is a ray of light which will reflect after 2 reflections, it comes out. So yes, B part actually is correct. It does come out after 2 reflections. Now moving to the C part, ray of light will never come out if theta is equal to 60 degree. And D part also talks about it. Ray of light will come out at theta equals to 60 degree for this after 6 reflections. So it has something to do with this theta equal to 60 degree. Again, the thing that I had assumed from symmetry earlier. They are saying if L is equal to L by 3 over here, will the ray of light never come out? Just imagine if it's going at 60 degree. As I discussed earlier also, it's going to reflect like this. It'll reflect as to become perpendicular. Then what would happen? Again, from symmetry, it is going to reflect like this, running parallel to the surface. Then again, it will reflect from over here. L by 3, all these distances will be L by 3, L by 3, L by 3, L by 3, L by 3. Then it is going to reflect from here. This will also be L by 3. And just imagine, using symmetry, again, this ray of light will come out. Is it that it will never come out? No. C part is wrong. A was correct, B was correct, C is wrong. And then moving to the D part. D part asks that for any ray of light, which is at a distance 0 to L by 2. L by 3 is also an option. Is it that the ray of light comes out after 6 reflections? Let's check. First reflection was here. Second was here. Third was here. Fourth was here. Fifth was here. And that's it. There's no 6th reflection. So D part also is wrong. The answer is just A and B. That is how it works. Moving to the 13th question now. 6 charges are placed around the regular hexagon. So there is this regular hexagon. And it's given like charges are kept on it. Charges are placed at equal distance by drawing perpendicular bisector on these from the center. So like 1 plus Q charge is present here. Similarly, 1 more plus Q charge here, another plus Q charge here, another plus Q charge here. This I would say is an easy question compared to all the others we had in this paper. This was also be categorized as easy. All these charges are equidistant from the center like this and follow this hexagonal symmetry. And what else is given? The side length of hexagon is given. This side length is given as A. And they're asking electric field at point O, electric field over here, and potential at point O. Potential they're asking for different values of the 6th charge X present over here. Okay, so here we have to use a little bit of principles of superposition and all. Let's see, first solve it for the part A. It will be important, first of all, to know the distance between charges and point O. You can use a little bit of geometry for it. You can imagine if I complete this equilateral triangle, this will be A, this will be equilateral triangle. So these sides will also be A. So then you can also imagine that this is going to be A sine 60 degree length. This length, let me call it L. L comes out to be A sine 60 degree. That is root 3 by 2. But this is not the distance that we were supposed to find. We were supposed to find the total distance between charge and this, which will be double of it because it's given that it is equal in the question. So here we can now say in the question, sorry, what's given? It's given X is equal to Q. For the value Q, what is the electric field? Verbally, you can do it. If it's Q, everything is symmetric. Electric field will be 0 at rest. So this is correct. Electric field will be 0. Moving to the B part now in the same figure. It says if X is minus Q, then what is the value of electric field? This becomes a bit tricky. And literally you can use a trick to solve. X equals to minus Q. What is the value of charge? Like what is the value of electric field? We will have to maybe calculate. But you can use superposition principle. What it says is, assume first of all that the sixth charge is plus Q. If the sixth charge is plus Q, then what will be the electric field? 0. So then it says, you can first of all consider plus Q charge to be present here. Claim that electric field is 0. But if you want to create this setup, now assume that there is this regular hexagon and there's a charge minus 2Q present over here. Why minus 2Q? Because minus 2Q plus Q earlier kept over here is going to give us the net same system which was in the question, minus 2 charge. Minus 2Q plus Q is minus 2. So if you find out the electric field at point O, just because of this minus 2Q, you get the answer. So this distance was 2L. So electric field, because of this, others have cancelled in the previous setup. Here the electric field is going to be the net electric field, KQ by distance square. So net electric field is K into charge is 2Q for this, divided by this distance 2L square, which is K into 2Q. In the question, you can see it was given in form of epsilon naught, pi epsilon naught. So K I will write as 1 upon 4 pi epsilon naught. Charge I will write as 2Q. 2 into L. L was root 3 by 2A. So root 3A whole square. So when you do the calculations, it will actually come out to be 6 pi epsilon naught A square Q, which is actually the B part. So B part also is correct. Now let's try for the C part. C part is actually about finding the potential. Potential at the center because of all these charges when one of the charges is 2Q. Now this is very, very easy. Finding potential is always easy. I should not say always, but yeah, most of the times it's easy. Plus Q plus 2Q plus Q plus Q. It's a scalar quantity, potential. We need to find it just by each of them and just add it. All are at equal distance 2L, 2L. So can I say that the total charge which is creating and is at equal distances Q plus Q plus Q plus Q plus Q, 5 plus 4, 5 plus 2, which is 7Q. So plus 7Q charge present at a distance 2L. So potential will be K into 7Q divided by 2L, which will come out to be, let's calculate, 1 upon 4 pi epsilon naught into 7Q divided by root 3A. So what is the answer? 7 by 4 root 3. Yeah, that is the option. So C comes out to be correct. And talking about the fourth one, D part, it is also similar. X is equal to minus 3Q. Basically, 5 positive charges Q are there. 1 negative charge 3Q is there. So what's going to be the total charge? It's going to be Q plus Q plus Q plus Q plus Q. 5 positive charges, but 1 minus 3Q. This comes out to be 2Q. So here the potential at center will be K into 2Q divided by 2L, which is 1 upon 4 epsilon naught root 3, 4 root 3. Okay. Magnitude wise it comes out to be correct. But see, they have put a negative sign here. That means it's the wrong. Because it is net positive charge, positive potential will be there. So A, B, C will be the correct answer for this question. So with this, we can now move to the next question also. Now this question is very much different from other questions that they generally ask in JEE, because it's like one of those questions where they assume a new effect in a particular phenomena which already exists in the JEE syllabus. So here, for example, it's based on binding energy, but in the binding energy concept, they start considering pairwise Coulombic repulsion. And they're asking what will be the difference in the binding energy of proton and binding energy of neutron after we consider Coulombic repulsion. So to understand this, let's see what all things they're asking, and then we will start with this question. Here they are asking us to find out the difference mostly in the binding energy of proton and binding energy of neutron. So why would there be a difference in the first place? First, try to understand that. What does binding energy measure? Binding energy used to measure stability of a nucleus, right? Binding energy, more the binding energy of a nucleus, more was the stability of the nucleus. But till now, we used to have binding energy of nucleons. Be it proton, be it neutron, it was the same. Why was it same? Because the force governing it was same. There, the force earlier, what we used to take till now was strong nuclear force. because of strong nuclear force, which is same for protons and neutrons. Binding energy was there. So more tightly they are bound with strong nuclear force, more will be the binding energy. But now they are saying that if inside the nucleus you consider the neutral neutrons, let's say 4, 5 neutral neutrons and 4, 5 protons also, positive protons, 1, 2, 3, 4, 5. So they are bound by strong nuclear force. But can you imagine, pair-wise they will repel each other also. These will repel. The first and second will repel. Second and third will repel each other. Third and first also will repel each other, and so on. Pair-wise repulsion will be there. So now they're asking us to consider electrostatic repulsion as well. Electrostatic repulsion. Now, how do we conclude that in this? So now they're saying that, okay, visualize it like this. Would the binding energy, would the force acting on neutrons be different if we start considering electrostatic repulsion or pair-wise Coulombic repulsion as they called it? Would it be affected? Would the neutrons be affected by it? No. This would be on neutrons. Like this would be the only force on neutrons. But on protons, both these forces will be there. Attraction will be there by strong nuclear force, but repulsion will be there by weak nuclear force. Sorry, not weak nuclear force. What am I saying? Because of strong nuclear force, there will be attraction, and because of electrostatic repulsion, there will be a repulsion. So can you imagine in this case, comparatively, protons are less bound, whereas neutrons are comparatively more bound. Earlier they were same, but now because of repulsion, it is less bound. So from this, we can say that binding energy of proton is going to be less than the binding energy of neutron, because they're less bound because of repulsion. So from this logic, this binding energy of proton minus binding energy of neutron should be a negative number. So this C is actually wrong. Now, what are they asking? Look at the D part. In the D part, they're asking, how does the binding energy of protons change if it undergoes beta positive decay? What is beta positive decay? Beta positive decay was whenever we had a proton converting into neutron and positron and a neutron. So just imagine the beta positive decay, number of protons reduce. If number of protons reduce, can we say there will be less electrostatic repulsion? Less electrostatic repulsion. And there's less electrostatic repulsion, there will be more stability, lesser instability. So can we say because of it, the binding energy of protons would actually increase? Because instability is less. It was reducing earlier because of repulsion. Now that repulsion is less. So on an average, for every proton, it increases. So this D is the correct answer. Now let's move to the A and B part. First of all, there are two ways through which we can actually think about this. And one of them will give us A option, other is going to give us the B option. If we think about the A option, they're asking about the difference in the energy of binding energy of proton and neutron. Now, why is there a difference in the binding energy? There is a difference because of the electrostatic repulsion. Now, neutron has more binding energy, proton has less. But here they're asking proton minus neutron, does not matter, the answer will be negative. That is going to be, see, why is the repulsion, why is this binding energy different? Because of repulsion between first and second charge, second and third charge, third and fourth charge, and so on, pairwise. So can you imagine, like pairwise, if we consider, we should like kind of, I don't know what exactly is the relation, but I know it is definitely proportional to thus K, Q1, Q2, Qi, Qj divided by R, average rate distance between them. It's given it's uniformly distributed, so average radius. So it's like average energy for each of them will be same, this total. But how many times does it get multiplied? It is going to get multiplied ZC 2 number of times. Because if there are Z number of protons, out of those you have to pick pairs of 2. So this will come out to be proportional to Z into Z minus 1 from permutation combination. So from this, A comes out to be correct in this. And if we talk about the B part, they're asking, is it proportional to this A to the power minus 1 by 3? So we can get it, like just imagine, they are saying protons are distributed uniformly. Doesn't it become like a solid sphere, solid insulated sphere with uniform charge distribution? So can I say that self energy of this? You can assume it like a sphere uniformly charged. So can we say self energy, which is actually going to be the difference in the binding energies, will be proportional to it at least. N minus B. This is going to be K into total charge square. What is the total charge? Z into A square divided by the distance, or I should say not the distance, I'm so sorry. In the formula of self energy, it was the radius of the shell, R. 3 by 5 was also there. 3 by 5 of this. 3 by 5. The formula for self energy was 3 by 5 KQ square by R. Now you see it's proportional to radius. But what is the radius of nucleus? If you remember that, it's like R naught A to the power 1 by 3. So from this we get that the energy difference En minus EBP is proportional to A to the power minus 1 by 3. So this B part also comes out to be correct. So the answer for this question should be A, B, and D. So now we are moving to the next section of it, which was match the following type. Single correct, but all the single correct were match the following types. Here you realize if you solve just one, because see, there are 4 parts technically. In list, there are 4 elements, but all 4 are already matched in 4 different parts. If we solve it, for example, we should always choose which particular option we are going to solve. Over here, like not a very great thing that we can choose. Okay, let's start with it. Then I'll tell you in the next part, in the upcoming questions, probably we can use this trick. What I mean is one can never be matched with R or P because it's not even given. So we need to check for a couple of them. If we solve 1 or 2 parts out of it, full questions answer we will get. So let's see how this is to be done. So over here, they are saying that there is this coil placed in the XY plane like this. In the XY plane, a coil is placed like this. So if it's placed in XY plane, you can imagine its area vector is the area vector given over here. Yeah, circular view of area. So area is given as A. That means the area vector for this is A K cap, because of course it's given as x-axis. So A K cap is the area vector. Now they're saying it's placed in a solenoid. And that solenoid is current in such a way that magnetic field is in this direction, in the n cap direction. What is going to be the value of magnetic field? It's going to be the magnitude of magnetic field, which is mu naught n. The formula for solenoid magnetic field is mu naught into n into I. N is the number of turns per unit length. It is given as m in the question. M into I, the current through it, I. And what is going to be the direction? Now that is the thing over here. Direction is variable. Why is that so? Because solenoid itself is rotating. As you can see, it is rotating about, this is rotating about different axes for these 4 parts. We are first solving it, for example, for the first part, where n cap's direction is 1 upon root 2 sine omega t j cap plus cos omega t k cap. Yeah, plus cos omega t k cap. Now what are we supposed to find? We are supposed to find the torque acting on this circular loop. Now, why would torque be acting on this circular loop? What's the logic? Why? When does torque act on a circular loop? Whenever it's placed in a magnetic field and it has a magnetic moment. If this coil has a magnetic moment and is placed in external magnetic field, it will experience torque. But does it have any magnetic moment? Is there any even current passing through it that will create a magnetic moment? Because if you know, magnetic moment is n into I into area vector. Unless there's a current, there will not be any torque or any magnetic moment. There is not given any magnetic, sorry, there's not given any current through it. So why would even current flow? It will flow because of electromagnetic induction. Actually, it's just saying that there's a magnetic field in this direction. But that magnetic field is variable with time because its direction is variable with time. So this changing magnetic field, not in magnitude, but in direction, will create an induced electric field, induced current, induced EMF. And because of that induced current, there will be a magnetic moment. And because of that magnetic moment, there will be a torque, M cross B. Just imagine, next level question over here. So let's see how this is to be solved. First of all, of course, we need to find the value of induced current. Resistance also is given for the same reason. You can see resistance of the coil is given. So we are first supposed to find induced EMF. What's going to be the value of induced EMF? Rate of change of magnetic flux, which is rate of change of B dot A, B vector dot A vector. What is going to be the value of B dot A in this particular question? So let's see. Magnetic field is mu naught Mi. But direction is a bit weird. Variable with time. 1 upon root 2 sine omega t j cap plus cos omega t k cap. Its dot product we have to take with area vector. And what is the area vector over here? A k cap. Okay. Little lengthy expression, but it's going to become a bit simpler in a while. Now see over here, we are taking dot product. So k cap, if you are taking dot product with only k cap term will survive, j cap will go away, dot product will be 0. So it comes out to be mu naught MIA 1 by root 2 cos omega t. So only variable with time is cos omega t. So when you differentiate, becomes omega sin omega t minus omega sin omega t. So this becomes mu naught minus mu naught MIA by root 2. Omega also comes out and it becomes sin omega t. That is the induced EMF as a function of time. If we found the induced EMF, we have found the induced current also. So the induced current in the coil, small I am representing it by, it's going to be minus mu naught MIA omega by root 2 R sin omega t. Current also we have found out as a function of time. Now once you have found out the current, you can find out, what have we found out? We have found out the current in this horizontal coil which was kept inside the solenoid. So its magnetic moment will be what? N into number of turns into current induced into area vector. What is the value of this? The magnetic moment is going to be number of turns, I think was not given, it was just 1. Yeah, it's not given, so we will assume it to be 1, as is actually obvious every time. So just multiply this with the area. It turns out to be mu naught MI A square omega by root 2 R sin omega t k cap. This becomes the magnetic moment vector. And then we are almost done. We have found out the magnetic moment. We will find out the torque. Torque comes out to be M cross B. Magnetic moment, this, take its cross product. Minus mu naught MI A square omega divided by root 2 R into sin omega t. I know, very lengthy expression. K cap. Cross product with this, basically you have to take cross product with magnetic field vector. Magnetic field vector is what? Magnetic field vector is this mu naught Mi into N cap. N cap was what? In this given question, it was sin omega t j cap cross. Yeah. Sin omega t j cap plus cos omega t k cap. So when we take the cross product, you can imagine k cap you're taking cross product with j cap will become minus I cap. But k cap cross k cap will be 0. Again, it's not that lengthy, a bit lengthy, but not that difficult in the end. So mu naught Mi constant, I'll bring it out. So this becomes minus mu naught square M square I square A square omega by root 2 R. And we are left with sin square omega t minus I cap. This we get as the answer. So the final answer is mu naught square M square I square A square omega divided by root 2 R into sine of, what is the value of t given in the question? It's pi by 6 omega. So we just substituted, get pi by 6 I cap. So the answer comes out to be mu naught square M square I square A square omega by 2 root 2 R I cap. Now in the question, there was given a value of this expression, I guess, something similar, by 2R. Yeah, that was given. So this comes out to be okay, but guys, I've made 2 small mistakes over here, and those mistakes are, I realize it. First of all, induced EMF, I should have put a negative sign over there. Like it should be minus d phi by dt. So there must be a negative sign carried since the very beginning in this question. So this magnetic moment will also come out to be positive. Then over here, this torque in this expression also, there will be one positive sign over here. So that means this, everything will become positive, negative, or whatever the previous answer was. This becomes negative, this becomes negative. One more mistake, it's sine square. I have taken it as sine. So it's going to be sine square. And then it becomes not this, becomes 4 root 2. So the answer comes out to be minus alpha by 4 I cap. So this is how you can solve this. This is how you're going to approach this question. For other parts also, you can try it second, third, fourth. If you just do, see, according to this, we are getting first will be matched to Q. So if first is matched to Q, then either B or C is correct. Second part, we don't need to check because P, P both are the same. Third part also I don't need to check. You just need to check the fourth part. Check what is the answer for the fourth part. If you get it, then you get the answer for this. Okay, out of A and C, any can be correct. You can check which one it is. Then moving to the next question, which is from kinematics from class 11th. So let's see what it says. There are these four questions in it. It's like, seems like a very, very lengthy question. 4 different questions you have to solve to get the answer. But first of all, out of these 4, you're going to pick up the easiest question so that you would do it in the least possible time. First question, if you see, matched with first part is matched to R, S, and T. Okay, so let's see which one it is. If it turns out R is the correct answer, then only option A. We don't need to solve it further. If one is matched to T, then also D is the correct answer. No need to check. If first is matched to S, then we will solve for second part to check if it matches with P and T, P or T. And accordingly, we will mark the correct answer. So let us start with the first part. Here they are saying there is a circular path on which 2 particles are moving in circle like this. Like here, the particle B is moving to the left with speed. Omega is given as 1 radians per second, radius is given as 1 meters. So you can imagine their speed also, everything we can imagine. But what are they asking? They're asking the possible magnitudes of relative velocities at t equal to pi by 3. Okay, see, here it's given. This is moving with speed 1 radians per second. This is also moving with angular speed 1 radians per second. So they will always move with 1 radians per second. So wherever they are, I don't know, this is a situation given at t equal to 0. Probably at t equal to pi by 3 seconds, they'll be somewhere else. But I don't care. Because wherever they are, wherever, it is still going to move with 1 radians per second. And at an angle of 90 degree, this will also be moving with 1 radians per second. That means if you find out the linear speed of them, V using V equal to R omega, their linear speed will come out to be 1 meters per second in this direction, 1 meters per second in this direction. So what is going to be the relative speed? So the relative speed, A with respect to B or B with respect to A, that is going to be vector A minus vector velocity of B, which since they have the same magnitude comes out to be root 2V. So that comes out to be root 2. It must be matched to one of the 4, matched to S. So that is what we were actually worried about. It matches to S. That means we need to proceed further to solve the second part of the question. If it is matching with T, then second is correct. If it matches to Q, then third one is correct. And we are done with the question. So technically, we just need to solve these 2. You don't even need to read third and fourth part. Here they are saying projectile is thrown, like 2 projectiles are thrown. This is thrown with speed. How much is given? Let's say some V at an angle of 45 degree. So where would the particle be after how much time? Pi by 3 seconds. After pi by 3 seconds, the particle will be where? It will be somewhere over here, moving towards right with V cos 45 degree and moving upward with V sine 45 degree minus G into T, which is pi by 3. These will be the horizontal and vertical velocities of this particle because it was thrown at t equal to 0. Now in the question it is given, the second particle is not simultaneously thrown. The second particle is thrown 0.1 second later. So when it is thrown with same speed V at same angle 45 degree, but 0.1 second later. So can you imagine after a while, its speed will be V cos 45 degree to the left, still horizontal remains the same, but upward speed is going to be V sine 45 degree minus G into not pi by 3, but pi by 3 minus 0.1 because it had 1.1 second less to stay in the air. So when we talk about the relative velocities, if this is A, this is B, this is the final velocity of A, final velocity of B. So when we do VA vector minus VB vector, their relative horizontal velocity will be 2V cos 45 because one is moving to the right with it, other is moving to the left with it. And their relative upward velocity, this particle actually will have a downward velocity. Its relative downward velocity will be just G into 0.1, which comes out to be 1 meters per second. And this is coming, this was moving with speed how much? 5 by root 2. So it is moving with 2 times 5 by root 2, 5 by root 2. 5 pi by root 2. 5 pi by root 2 into cos 45, which is 1 by root 2. This comes out to be 5 pi meters per second. So rightward velocity is 5 pi, downward velocity is 1. So can we say that the relative final velocity will be root of Vx square plus Vy square, which is root of 1 plus 25 pi square. Let's see if it matches with one of the four options. It does with T. So that means B part is not correct, C part is right, because second matches with T. So that's how you can solve it. Not a difficult question. I would consider it as an easy question only. Just two small questions are present in this. Then you can solve and get it. Now moving to the second last question based out of thermodynamics. Yeah, again, those who love thermodynamics would definitely go with this question. I would definitely have gone with this question. And let us see how this is to be solved. So over here, there are, let's see which part we can solve. First part matches to T, S, P, Q. Oh, that means we need to just solve one of the, let's the first part and we get the answer. So let's just do it. Let's try the first part itself. Here it's given 10 to the power minus 3 kg of water. Like there's some mass 10 to the power minus 3 kg of water at 100 degrees Celsius. So this is getting converted into steam at the same temperature. Of course, it's like converting into steam. Temperature would not change as such. But at a constant pressure, 10 to the power 5 pascals pressure is there. The volume also changes from, like, it kind of becomes 1000 times, 10 to the power minus 6 to 10 to the power minus 3. Suddenly it increases. We are supposed to find change in internal energy in this process. So what must be happening over here is, see, we are supposed to find the change in internal energy of the system. Okay. Now, what are the possibilities? First of all, it is gaining heat. Gains latent heat, right? Because it's converting into steam, latent heat. Where is, like, how much will that be? That will be mass multiplied by the latent heat of vaporization. Mass is 10 to the power minus 3 and latent heat of vaporization is 2250. So this comes out to be 2.25 kilojoules of heat is taken in to evaporate. What else is given? It is given that the volume actually expands. Volume has expanded. Yeah. So just imagine if the volume is expanding at a constant pressure, do you not need to give some heat to it? Some heat needs to be given to it. So let's say, because the gas is expanding, there must be work done by the gas. Work done by the gas because it is expanding by itself. So work done by the gas, guys, in this case is pressure, the constant pressure multiplied by the change in the volume. The constant pressure is 10 to the power 5 and the change in volume is 10 to the power minus 3 minus 10 to the minus 6. This is approximately 0 compared to it. So this comes out to be 10 to the power 2 joules, which is basically 0.1 kilojoule. So 0.1 kilojoules of work is done by the gas. So then we will apply the first law of thermodynamics. First law of thermodynamics. According to that, we can say heat that you're giving, the latent heat basically, must be going to the change in internal energy plus the work done by the gas. So from this, it turns out that delta U is 2.25 minus 0.1 kilojoule, which is basically 2.15 kilojoule. Since we have to answer it for the close approximation, this matches with P. So that means C is the correct answer. And we get the answer. And now moving to the last question, which is, I think, again, one of the simplest questions there is in this whole paper. And we can solve it for, again, one of these parts, and then probably we'll get the answer. Let's see. Either one matches to P or Q or T. Let us check what it matches with. In fact, in this question, I would say better than using this approach of solving for this part. Choose which part you want to solve. Which one is easiest to solve. Okay. I'll tell you what actually I mean by this. See, if you look at the second part, second matches with P, R, S, T. It must be one of them. So probably you should solve it for this part, or you should solve it for fourth part, because in fourth part also all four options are different. So whichever you're comfortable with, second or fourth, you can solve it for it. I'll do it for the second part. In the second part, they say, because if we solve second, we have got the answer for the question. We don't need to solve it for anything else. Here it's given there's a convex lens having focal length plus 10 centimeter. Object is kept at a distance of 20 centimeter from it. Now, those who are like in a lot of hurry and who are not focusing on the paper right now, just trying to get some answer, would never be able to find this trick. That in this case, it's given object is at 2f distance from the lens. So if object is at 2f, image will also be at 2f. The first image will be at a distance of 20 centimeter. No need to use any lens equation. But there was one more lens given, concave lens. So you know, for this concave lens of focal length minus 10, this image, because the distance was 5 between them, between these two the distance is 5. So the distance of this object for concave is going to behave as image, this image is going to behave as object for the concave. So for the concave lens, if I write the equation, for this only I need to write the equation. I'll say object is 15 centimeter to the right, 15 centimeter. 15 centimeter to the right. The focal length is minus 10. So I'll use 1 by V minus 1 by U is equal to 1 by F. So when we solve it, 1 by V is 1 by 15 minus 1 by 10. This will come out to be minus, comes out to be minus 30 centimeter. Okay, so 30 centimeter to the left, R must be the correct answer for this question. And that is how we get. So if second is being matched to R, then A is the correct answer for this question. And that's it. Very, very simple question. This. So that was mostly it. In another video, we are going to discuss the solutions of paper 2 of this JEE Advanced 2022 also. So let's catch it up over there.